right. Today we're going to start our second part of chapter 9. Guys, we're doing the same thing that we did in the first part of chapter 9. There's just one small difference. Instead of dealing with proportions, we are going to be talking about means. Same methods are going to apply. There's just one little change. All right, so let's go ahead and start this problem. This one is just going to be the basics, and then I'm actually going to finish this problem in video number 6. So let's go ahead and get started. In a random sample of 25 high school students, the typing speeds followed a normal distribution. The mean typing speed was 60 words per minute, with a standard deviation of 8 words per minute. Create a 95% confidence interval for the mean typing speed of all high school students. All right, so in this sample, here's what happened. Our mean for this sample was 60 words per minute. Words per minute. However, if I were to sample every single high schooler in America, every single high schooler, it is very, 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 very unlikely that if I were to add up all of their speeds and take the mean of them, that it would be exactly 60 words per minute. So what we're going to do is we're going to turn this into a confidence interval. What's my lowest that I would expect and what is my highest that I would expect? All right, so this is going to start off the exact same way. If I'm looking for a 95% confidence interval, here we go. We want 95% to be on this side, or in the middle. And then I need to discuss my two tails here. What percentage is left for my tails? All right, well, looking at this, if 95% is in the middle, that means that I have 5% for both of my tails, which really means that we have 2.5% for each tail individually. And then that would add up to 100%. Now, this is the part that if we were doing a proportion, we would need to find this critical z-score. However, there is one difference. There is one very, very small difference about doing a mean versus a median, or a mean versus a proportion. So when we are discussing an interval for a proportion, that is when we use our normal distribution. However, if we are doing an interval for a mean, we are not going to be using the normal distribution. We are going to be using something called student's t-distribution. And there is kind of a fun story about the creation of the t-distribution. It actually came from a man who worked for Guinness Brewing. He was very limited on the number of samples that he could take, and he noticed that for means, there was a little bit of a difference between the normal distribution and t-distribution. So I'm going to go ahead and show this out. A normal distribution looks like this. If we were to zoom in, normal distribution is nice and symmetric. Now let's talk about a t-distribution. A t-distribution, t-dist. All right. And what it is going to be asking for, is enter the degrees of freedom. Well, I'm going to go ahead and say that the degrees of freedom is 1. And if you notice our t-distribution with a degree of freedom of 1, the tail is a lot bigger. It's a little bit shorter in the middle. And as I increase the number of degrees of freedom, it gets closer and closer and 10. It gets closer and closer and closer to the normal distribution. It's still not exactly the normal distribution. If you zoom in real close, the t-distribution is still a little bit underneath it. But the t-distribution changes depending on degrees of freedom. Now you might be curious, what the heck is a degree of freedom? Guys, the degree of freedom, for our degrees of freedom, that is just the number sampled minus 1. All right, so looking at this one, our degrees of freedom here, we have a random sample of 25 high school students. So my degrees of freedom is n minus 1. This means that I would have 24 degrees of freedom. All right, and that is my t-distribution for this problem. I'm going to go ahead and exit out of my normal distribution. All right, so now that we have our t-distribution, With 24 degrees of freedom, there are 25 high school students that were sampled. We would need 24 degrees of freedom. Let's go ahead and find what t-score is my critical value here. So first thing, you need to name your distribution. I'm boring, I'm going to name it A. Just like we have in the past, this will be inverse CDF. All right, inverse CDF, we're looking at distribution A at 0.025. And there is my critical t-value, that is negative 2.06. So right here, this is negative 2.06. That is my critical t-value. All right, so I'm going to change this problem and we're going to do it again. All right, change this problem and then we are going to do it again. So here we go. Let's go ahead and talk about, let's say in this case we sampled, we'll go with 125 students. And then let's say that I want a 99% confidence interval for the mean typing speed. All right, so a few different things. I'm going to go ahead and just draw kind of a sketch. All right, pretend that that was better than it is. All right, so 99% confidence interval, here we go. So 99% confidence interval means that I want 99% here. What is left for my two tails? Well, my two tails, there's 1% total between those two, which means that there is only 0.5% left on the tail. All right, so let's go ahead and come on over to Desmos and figure this out. All right, first off, my t-distribution. I sampled 125 students, 125 students. So for my degrees of freedom, I have 124. All right, inverse CDF. All right, I'm talking about my t-distribution. I named that A. And then finally, if I want 0.5% on my endpoint, here we go. That would be 0.005. And that critical t-score is negative 2.62. So that one ends up being, this critical value is negative 2.62. All right, so you should have enough information to do the first assignment on video number 5. It is just talking about how to determine degrees of freedom and then also how to find that critical t-score. Please let me know if you